Hi, my name is Carl Eriksson. I come from Svenska Elektrod and I'm here to talk to you about the Smooth tool from Smooth Robotics. Smooth tool is a piece of hardware and a piece of software that connects your welding machine to the universal robot arm. So the software enables us and helps us to connect with any sort of power source. What you can see here right now is that we have set it up with a Kempe welding machine, but we could have also connected it to an ESAB welding machine, a Fronius welding machine, or we could have connected it to any welding machine with the digital input and output setup. This is if you have a welding machine where you can remote control it. It might be an old welding machine, but something that you can connect and start and stop welding, then you can actually connect it with the Smooth tool. So what we can see here is the actual flange, the Smooth tool flange, the hardware. You have two buttons blinking. The blue button is to confirm all the air points for the robot arm where we're not welding, but it's also for setting linear welding positions. The red one is for confirming and setting circular welding points. So we can seamlessly go about setting our waypoints, whether they're linear or circular, in a continuous fashion without using the teach pendant of the robot arm. On the back side is the free drive button. This button allows us to move the robot. So this robot arm, you cannot move it unless you hold and push the black free drive button on the back side of the Smooth tool. Let's go into programming our setup. In order to program your welding, you'll go into Program node and you'll see an empty program tree. When you go in, you use the UR caps node in the left-hand pane, and then you click Smooth tool. What this does is it opens up a number of parameters that you need to actually weld. So what we want to do is we want to define different items. An item in Smooth tool is a weld. So here you'll have your different points explained to you. So you have the initialization point, the init point, which is a point away from the weld, somewhere where it's safe to move to from your current location. Then you have your start point, which is the point where you will start welding. You have the end point, and then you have the item endpoint. So the difference between these are that this is the welding endpoint, and this is the item or the initiation point away from the object. So similar to the initiation point, to the respect that it's away from the object in a safe position, but this one is after you've actually welded. So if we click the initiation point, you'll see that the blue button on the robot is actually blinking. So if I move this one to a location away from the weld and then click the blue button, it starts blinking slowly. And you can see in the software that the node initiation point is no longer yellow. It's actually white, which means that it has already the points needed. If I were to click the blue button again and set another location, you can see in the teach pendant that I've put a new point, which now enumerates after the initiation point. This means that if I need to go a more complex route in order to avoid certain objects or something in my welding table to get to my welding location, I can do so by setting a number of blue initiation points. Now, I want to go to my weld and start welding. So I mark the path start point and I direct my weld. Let's just cut off some of that excess wire. I direct my welding gun to where I want to be welding. For example, there. Now, if I'm satisfied with this location, I'm just going to click the blue blinking button. And now, what you can see is that the blue button and the red button blinks alternately. This means that the smooth tool is asking me, is this going to be a circular weld or is this going to be a linear weld? In this case, it's just going to be a linear weld. So I can actually just move the smooth tool by holding the free drive button to the last location of the weld, and then click the blue button. So if we now look in the teach pendant, you'll see that both locations, the path start point and the linear one, is actually white. They were yellow. This means that now I have all the parameters set for this weld. And we just need to set our item end point, which was the location away from the weld where we can move safely. So what we do is we gently move it up. We take a blue point, and then we can move it up to here, for example. I didn't tell you that, but I also set the last point with the blue button, which means that you can see in the program tree that point 2 was added after item endpoint. And this was in the same fashion as I added the point 1 after initiation point. Now, if I go back to Smooth Tool, you can see that everything now is white. This is confirmed that, okay, the welding is now ready to be started. So in any other robotic application, what I would do now is to simulate everything. I would set the welder in simulation mode, and then I would start the program and just run through all the parameters. Now there is a very, very special feature to Smooth Tool, which is the 3D visualization parameter. So I can actually hit 3D, and I can now look into my program what it looks like before simulating it. So I see my green initiation point. I can see the point 1. And what you can see here is also the blue lines representing the air points. So all the blue lines represents ways of travel in air without any welding happening. The red symbol here, or the red line, is actually where the welding is happening. So in this way, we can actually check our programming without having to simulate the program whatsoever, which is if we have long welds, it would be very time consuming to simulate everything. Then we can actually just check it here. So before going into welding and before simulating it, I just want to show you some other parameters that you can set in Smooth Tool. So on the actual item level, we can set parameters for the weld, and these will be item specific, which means that you can subsequently go into welds within that item and define them specifically. But if we want to have the same parameters on all the welds within this item, we'll set them on the item level. So we go into parameters, and we can select our travel speed. We can select the acceleration of the tool. We can select maximum speed, and we can select the blend in radiuses, etc. Here we can also define if we want the weld to be a zigzag weaving pattern on all welds. We can select it to be a crescent weaving pattern, or we can select it to be a stitch weld. Let's keep it to stitch weld because I want to stitch this before we weld it fully. Now, in the stitch parameters, you can see that we can set an airspeed, which will then be the speed that the welding gun travels in between the welds. We can set the retraction length, so how much will it retract in between each weld. And we can set each weld length. And then, on the last one, how many welds should the weld be split into. In this case, it's 5 welds. I think it's a little bit too much, so let's set it to 4. Now, if we go into Smooth Tool and we click 3D, you can see, no you can't because I made a mistake. We need to go in here and we need to apply it here on stitch, on the actual weld. So these parameters that we set over here is just the stitching parameters, but we still need to activate the stitching on the actual weld. So now if we go to the 3D in Smooth Tool, you'll see that the weld is divided into 4. So you'll see 4 little weld seams being 10 millimeters each, and everything in between is just an air movement. So now we can actually go up here to the UR plus icon and we can click simulation, and now we can run our program without activating the power source. We hold the move robot into position and now we can start it. The gun goes in, does the 10 millimeter, retracts, goes in, does 10 millimeter, retracts, does the 10 millimeters, retracts, goes in and does the 10 millimeters. And then it's done. So I just want to change robot program from looping forever. Now, we have already connected our setup to the Kempi power source. But if we want to control all the welding parameters on the actual power source, we can do that. Or we can actually bring in the welding parameters and control them from the Smooth Tool itself. What we do then is on the left-hand side in the Weld Parameters pane, we click Weld Parameters, and then you'll see you get up a Kempi node. Now, the input parameter section here is actually the parameters that we get from the power source. Right now, we're not enabling anything or any decisions being made on those inputs, but in the future, we'll be able to use that to guide ourselves in the welding. The next hand, the output, that's actually where we will put our input into the machine. So either we can select memory channels. So for example, memory channel 0 will then trigger the memory channel 0, which I've already set parameters for in the welding power source. If I were to go into online control instead, I would be able to set the voltage, the dynamic, the wire feed speed, etc. and have this sent from the welding program in our universal robot setup. Now, I don't want to use the online control. I want to use the memory channel for this setup. I click apply. This then directly translates into the welding power source, and we're actually good to go. There we go. Let's try this out. Just activate the suction. So what we did now was actually do the weld with the settings in memory channel 0 on the power source. Now we've stitched welded together. What we want to do now is we want to weld the same portion, but we want to do it continuously. The only thing I need to do is go into the smooth tool and go into the actual weld and then just remove stitch welding. If we now go into the smooth tool and check the 3D, you'll see that it's fully welded. It's not stitch welding anymore. It's going to be fully welded, like so. So let's run the program again. So without doing anything, we just changed one parameter, which is going from stitch welding to full welding. We now have our weld completely welded. Just for the sake of it, I'm also going to show you how to now add a weave on top of this. So we might want to change some of the positions, the stick out, for example. So let's just go into how we want to change those positions. So in the program node, we know that the path start point, that's the point where we're going to be starting welding. So what we go in here and we hit edit point. When we go in here and hit edit point, whichever point I now set will now be the new welding start point. So I don't want to be starting up here, and I want to set my new point with reference to the first one. So let's click cancel and then go first to move to point. This will now move the robot into position to the first position where we're going to be. Okay. So we're down here and we want to have a little bit difference in this point. We click the edit point and we'll go into, instead of using feature on the referencing, we'll use the tool. This now means that if I go in Z, if I were to go in Z position or Z axis, normally I would go like this, right? Z up, Z down. But now I'm referencing the setup to the actual tool, which means that the Z axis will be in the stick out direction. So now we can actually add a little bit of stick out. Something like that. If I now click OK, that will actually be my new position, the welding start point. Now I want to change the last welding point, and I go to move to this one, and as I did with the last one, I click edit endpoint and I retract it a little bit, something like that, maybe a little bit closer, something like so. I'm good with that one. The rest of the points can actually be the same. So now let's add weaving. And in this particular case, I want to use the crescent position or the crescent parameters setting. So it can be a little bit hard to define these parameters from the start, but as we have the 3D visualization feature in Smooth Tool, let's use this. So we go into the Smooth Tool node, and we check the 3D parameters. And then we can actually go in and see what this will look like. Yeah, that doesn't seem too far off. But as this will be a weaving pattern, we want to increase our speed a little bit, the travel speed. So let's go into the specific weld and overrun the parameters that we already set. Let's go up to maybe 12. There we go. And check it. Everything is fine. Let's do the weld. I have the suction. So there you have it. We did the stitch welding, we did the full welding, and then we did the weave with the crescent pattern, all with the same points within just a fraction of time. So in order for you to help to just automate your welding, whether you have a new power source or you have an old power source, the smooth tool can really help you with that. We're going to do a lot of these videos showcasing all the different setups, all the different techniques, etc. But this was just to showcase the basic setup with all the different parameters available to you. So with that said, thanks a lot, and tune in again to see all the different aspects of the smooth tool. Bye.